System of units. Before consensus was reached internationally on the system of units which were to be followed by all countries, several different systems were adopted by countries. Some countries followed the CGS system of units. This system had the base units for length, mass and time as centimeter, gram and second respectively. Another system of units used was the MKS system, which had the base units for length, mass and time as meter, kilogram and second respectively. The system adopted by the British was known as the FPS system, standing for foot, pound and second respectively. All these systems were eventually replaced by one standard system, followed by the entire world, known as the SI system. SI is an abbreviation of Système International d'Unités, which means International System of Units in French. This system was developed at the General Conference on Weights and Measures in 1971. All SI units follow the decimal system, unlike other systems of units. This makes conversions within the system easier. The SI system is made up of 7 base units. These units are shown in the table above. The SI unit for length is meter, which is the distance traveled by light in vacuum in a time interval of 1 by 299,792,458 of a second. The SI unit of mass is kilogram, which in turn is the mass of the international prototype of the kilogram kept at the International Bureau of Weights and Measures in Sèvres, France. Time has the SI unit second, which is the duration of 9,192,631,770 periods of radiation corresponding to the transition between two hyperfine ground levels of the cesium-133 atom. The SI unit of current is ampere, which is that constant current which, if maintained in two straight parallel conductors of infinite length, of negligible circular cross-section, and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 × 10⁻⁻⁷ Newton per meter of length. Temperature has the SI unit Kelvin, which is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. Amount of substance is measured with the SI unit mole, which is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon-12. The SI unit of luminous intensity is candela, and is defined as the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 × 10⁻12 Hz, and that has a radiant intensity of 1 by 683 watt per steradian in that direction. In addition to these 7 base units, we define radian as the SI unit for a plane angle, and steradian as the SI unit for a solid angle. An angle of 1 radian is obtained in an arc with a length equal to the radius of the circle. Similarly, a steradian is defined as the solid angle subtended at the center of a sphere of radius r by a portion of the surface area of the sphere whose area A equals r squared. All measured quantities have units which are derived from these base units. This means that all other units of measurement that we encounter are a combination of these fundamental base units.